I'm here as usual. Call me Teacher Saban. And with me on this chat, there is a competence-based question. Dear teacher of science, how can you know that a question is competent of a competence-based curriculum? If that question, for example, assesses the following skills: problem solving, effective communication, critical thinking, creative thinking, and many more, as reflected in that curriculum book that we are using. And that's why such skills are put in that book, or were put in that book by NCDC. So how will you develop these skills in the learners? Because there is nowhere you go to class and you say, children, oh, my class of P7, today we are going to look at problem solving or critical thinking. No way. These skills are assessed or are developed as we teach these learners, meaning that the methods we use also matter a lot. The instructional materials that we use also matter a lot. And that's why if you want to teach in line with a competence-based curriculum, you should think of child-centered methods. For example, demonstration, group work or group discussion, the project, the experimentation. Those are some of the methods that will help you develop the following skills in your learners, and which is in line with competence based. So without wasting time, this is a diagram. It is illustrating one of the properties of magnets, and your lesson would look beautiful or more practical, more real, if at all you are using real objects. And in case you need a science kit, inbox me, talk to me. 0783 415 740. 0783 415 740. That is my WhatsApp line, or my line I normally use. And in case also you want to invite me to that school and I conduct a workshop with those teachers of science, with the candidates, then we move together, we share science, we enjoy science, we talk science in a modern times. So this is a question, as you can see below, is an experiment carried out to show one of the properties of magnets. So you can see this is the bucket, a transparent bucket. These are iron pins. This is a bar magnet. And whenever you want to conduct a successful experiment with your learners, ensure that the first step, you should first identify or help learners to identify the materials, the items. And at a certain level, advanced level, this is what they call the apparatus. And make sure that each item you have used help these learners to know, to explain the purpose, the importance of each item as used in the experiment. Help them to know that, for example, minus this magnet, what do you think will happen? Ask them, tease them with questions even, that why don't you think, what do you think will happen if we use an opaque bucket? Why do we use a transparent bucket? Give them time to generate their answers, to think, and give you their views, their answers, so you can build on their answers, on their responses. And what you are doing, you will be developing critical thinking, you will be developing effective communication, because they are giving you answers. I have clearly told you that in science, how does effective communication come in? Like the way I'm doing now, public speaking. When learners are speaking their answers, their mind, their views, they are communicating. If you tell them to draw like this diagram, they are communicating. Listening is part of effective communication in a science lesson. Labeling diagrams, they are communicating. So when we say effective communication skills, that's what we mean, dear teachers of science. So ensure that learners develop these skills, because we normally experience challenges when these learners are even attempting the final paper of integrated science. They find problems in expressing themselves on a piece of paper. For example, I can ask this question in a different way. I can say you are provided with the following materials: a transparent bucket, iron pins, a magnet, and a table. Describe an experiment to show that magnetism can pass through non-magnetic materials using the items above. And the question is taking like 4 marks. That is also possible. So as learners try to attempt that question I have asked or stated, there are problems in expressing answers. Others write as if they are writing a passage. Others write, they repeat the items you have provided or that are reflected in the question. Something that informs me or tells me that as teachers of science, there is a lot we need to do. Because most teachers I interact with, they will tell you that they are already done with that topic. They are almost on the last topic of energy resources, which is okay. But I normally tell them, if I'm to assess your learners in areas, in the topics you have covered, are we safe? And so far as you have seen or you have heard, with the question I have stated, that one of describe, I don't think learners or your candidates can pass it with ease. You try it, you will thank me later. The good thing, I've given you my phone contacts. You can talk to me. I also have a WhatsApp mentorship class. You can as well call me and we talk business. So without wasting time, let's go to this question. So you have seen the layout of the experiment. After showing these learners the items or the materials to use, then you can now go to the drawing, or if you have a chart, you would have drawn that question, that diagram on a piece of paper like the way I've done, in order to save time. You are supposed to do that before the lesson. So as after showing these learners a magnet, the transparent bucket, and even conducting the experiment, now you can put a chart or display a chart. That's how we can use real objects first. From real objects, then we go to visual learning aids or man-made. Visual learning aids, for example, a chart. So question A, state one property of magnets shown above. What is the answer? Magnetism can pass through non-magnetic materials. As simple as that. 1 mark. Which level of question? Knowledge-based question or recall question. Candidates are supposed just to remember, to recall a property of magnets. There is no critical thinking or a lot of thinking involved in trying to come up with the answer. It is just recalling a fact, a property of magnets. Then part B, explain how pins were attracted to the magnet although they were inside the bucket. 2 marks. So that's where candidates have challenges also. And which level of question? Comprehension question, understanding question. And comprehension question, understanding question is an high order thinking question. It requires a lot of thinking. First of all, this question requires candidates first of all to understand magnets. It requires learners to understand properties, all the properties of magnets first. Then out of the many properties, which one is that one? Then at the same time, how can, for example, this pin, how can this magnet be able to attract the pins which are inside the bucket? So you can see there is a lot of thinking. Learners need to explain their understanding. They need to explain how this one is possible, how this magnet will be able to attract the pins inside the bucket. So it requires a lot of thinking or brain work, as I may say. What are the answers, or what is the answer? And the question is taking 2 marks, and it is a comprehension or an understanding question. The magnetic force passes through the plastic bucket and attracts the small pins inside it. As simple as that. What could be some of the challenges, in most cases, displayed by the learners as they write their answers? Some may say the magnetic force passes through the bucket. They end there, 1 mark. Magnetism passes through the plastic bucket, 1 mark. So the learner needs to explain in his or her own words. By doing that, that child will earn 2 marks. The last question, which is also an application question. Why application question? These learners, we understand, or we assume, they studied the properties of magnets. They got that knowledge. How can this child apply this knowledge about the properties of magnets? More so, magnetism can pass through non-magnetic materials in real life, in solving daily life problems. I told you that application questions are problem solving questions. They require candidates or learners to apply the learned knowledge in real life, in problem solving. And that's why it is an application question. An application question in integrated science is an higher order, or it is a high order thinking question. What are the answers without wasting time as I wind up my videos? The first response is, it is used to separate iron materials from wastes. Or a child can say, it is used to separate magnetic materials from non-magnetic materials. It is used to separate magnetic metal scraps from non-magnetic metal scraps. It is used to separate a mixture of iron filings and flour. It is used to separate or to remove iron pins, iron nails from sugar crystals. Because in P5, we normally teach them that using a magnet is one way of separating solid mixtures. You can even remind them that concept, that thing which they learned in P5. Then the last response, it is used in magnetic doors, or it is used in closing and